Hello my dear students, chapter number 13 and topic number 4, that is electric motor of subject science 10th standard. Electric motor, this is the very common item that we used to see in our household appliances, right? This is the electric motor which we generally use to drag water from sump to lift it up to our water tank, isn't it? So let us now understand, let us talk about the electric motor. Basically, it is very clear that this is the capacitor, this side is a fan, this is the main body of a motor. So water will come inside this, pump will just give it boost, give it a force, and it will come outside through this point, output, right? So electrical motors are of two types, AC motor and DC motor. Electrical motors are of two types, AC motors and DC motors. Why these are the two types of motor? Because there are two types of the supply. One is alternating current and second one is the direct current, right? We have already learned that in case of the alternating current, current will be positive, negative, and so on. We are getting actually 50 hertz supply in our house, means there will be 50 positive cycle and 50 negative cycle. We will be getting one positive cycle in 1 by 50th second, means there is a frequency of 50 hertz, means positive 50 parts and negative 50 parts, right? This is the way we are getting frequency. So in case of the alternating cycles, there will be positive and negative half cycles. Whereas in case of the DC, there will be no change. Current will be constantly flowing only in one direction. In case of the AC, direction of the current will keep on changing. So what is the DC motor? DC motor is the device which converts the direct current into mechanical work. Means direct power into mechanical work. If we would like to define simply motor, then we may say a motor is an electrical device. It's an electromagnetic device which converts electrical energy into mechanical energy. Repeat, what is the electrical motor? Electrical motor is an electromagnetic device or simply electric device which converts electrical energy into mechanical energy. Here we are talking about the DC motor, so I have used the word DC motor. Otherwise, in exam you will have to simply write an electrical motor is an electrical device or electromagnetic device which converts the electrical energy into mechanical energy. So simply transformation of electrical energy will take place into mechanical energy, and it works on the principle which states that the current carrying conductor placed in a magnetic field experiences a force. Actually, this statement was given by the Lorentz. What did he say? We had already seen the previous video in which we had suspended a current carrying conductor and we had kept a horseshoe magnet. We found that whenever there is a suspended current carrying conductor, it definitely creates a magnetic field around it, and when we bring another magnet, a real magnet, towards it, what we do observe? That it exerts a force, it experiences a force. Which one is experiencing force? Both of them. So which one is the lighter will move away, right? So this statement was given by the Lorentz. What did he say? That the current carrying conductor placed in a magnetic field experiences a force, right? Now, according to left hand rule, if central finger represents current, CC, central finger represents current. Forefinger, this is the forefinger or first finger. First finger or forefinger represents the field of what? Magnetic field. And if thumb, M represents the motion, force, then we may say that if these three fingers are placed perpendicular to each other, if these three fingers are kept perpendicular to each other, central finger represents current, direction of the current passing in a conductor, forefinger or first finger represents the direction of magnetic field north to south, right? And then the force which will be experienced by this current carrying conductor will be given by this direction of thumb. Now let us try to understand that in a real way. So See, this is the motor. This is the electrical diagram of a motor. It is very clear that this is the north pole and this is the south pole. So definitely the direction of the magnetic force, direction of the magnetic lines of force will be from north to south. Direction will be from this north to south. Now, so this is the direction of magnetic force. So F represents the direction of the magnetic field. Now, let us talk about this conductor. Let us talk about the conductor which is near the south pole, right? If current is, say, passing in upward direction, this direction, because see, this is the positive terminal of battery, it will pass through a brush commutator and then it will flow like this. So when current will start up in upward direction, inside the paper, inside the screen, this way. So if this is the direction of the field, now what is the direction of the field? Direction of field, that is first finger. First finger, north, this side north and this side south. So north, south, direction of the field. Central finger, current is going inside the paper, current is going inside the screen. So inside towards you. So if this represents central finger, that is current, that is going towards this direction, field this direction, then that conductor will experience force in upward direction. Then this conductor will experience force in upward direction. It is very clear. You can see that yes, it is experiencing force in the upward direction. Now let us talk about this conductor which is towards the north pole. Again, this is the direction of field, right? North to south. Now current. Now the current is in this towards the this south pole. It was in upward direction. Now it travels like this and the direction is changed. The direction is coming out of the paper or coming out of the screen, right? Like this. See, this is the direction of the current. This is the upward direction, then transfer direction, then it will be coming out of the paper or coming out of the screen, means towards out of the screen. So four finger field is the same. Current is something like this. Current, direction of field, current is something like this, right? So now this motion will be represented by thumb like this. So direction of movement of this conductor will be toward downward direction. So if we now combine both this direction, we can easily observe that the conductor towards the south pole will experience upward force and conductor towards the north pole will start facing downward force. So what will happen? This coil will try to rotate. This coil will try to rotate, and when it will rotate halfway, situation will again be reversed. Why? Because now the conductor which was getting current like this has been shifted towards the S pole. So now it will start getting current in this direction. So now it will start again getting this direction force, right? So in this way, this coil will start rotating like this. And why it is rotating? Because it is a current carrying conductor, it is a current carrying coil placed in a magnetic field, and according to Lorentz law, whenever there is a current carrying conductor placed in a magnetic field, the current carrying conductor will experience a force and it will start moving. In this case, it will start rotating, right? And what do we observe? We observe something like this, that whenever there is a magnetic field, whenever there is a current carrying conductor, it will start rotating. Means electrical energy has been converted into mechanical energy. And this is the way we can understand that you can see this is the north pole and south pole. So you can find out the direction with the help of the Fleming's left hand rule, right? Four finger field, central finger current, and motion, right? So you try now, just pause the video, stop the video and try to find out the direction. I have kept it just opposite to what I had given example, so that you can try by your own and you can verify the direction of movement of this current carrying conductor or current carrying coil. Just try to do this example by your own. So now let us talk about the commercial motor. What we had learned so far is that of the ideal motor. Now let us talk about the commercial motor which we used to see in our homes. Actually, electromagnets are used in place of permanent magnets. Actually, we had seen that there were permanent magnet N and S, but in real practice we don't put permanent magnets, then it becomes very costly and very heavy in the nature. So you actually put electromagnets, means electricity used to make the poles N and S, and one more part of electricity will be used to rotate the coil, right? To rotate the conductor. Large numbers of the tons of the conducting wire in place of the current carrying coil. Instead of single ton, we are keeping large number of tons. Why? So that there will be huge amount of the force will be produced, so that it will give more force. Soft iron on which the coil is wound is known as the armature. So what is armature? Armature is nothing but a soft iron core on which certain coils are wound, and due to this soft iron core, the power of the motor gets increased. See, this is the cutout sectional view of electrical motor. You can very clearly see that this is the armature in which windings are kept. This is the fan to keep the motor cool. These are this and this. They are the bearings on which this current carrying conductors will be rotating. And what I was talking about, the electromagnets, yes, these are the actually electromagnets. Actually, they are poles. Current will be given to this and they will come poles, and they will just behave like permanent magnets, and under the effect of magnetism of these electromagnets, this armature will start rotating and we will be getting movement over this shaft. And these are the pins to keep the motor cool, and this is the foundation of a motor. This is the another view of motor. See, we can easily find out bearing, shaft, then these are the windings to make the electromagnets, and armature. Armature, actually it is wounded with the coils. This is the third view of motor. These are the side enclosures, this one and this one, left and right side enclosures. Certain holes are there for the ventilation of the air. See, these are the windings actually which are used for making the electromagnets N and S pole. Actually there will be numerous poles. There won't be only two poles, but there will be more than two poles, so that we get maximum rotation. This is the armature in which we keep conductors. Conductors are actually spread. Conductors are actually passed in this armature, and that experiences the force due to which they start moving. For more such videos, keep watching Free Education by Akash Sir. Thank you very much for watching. Remember, I would like to remind you that you will have to watch this type of the videos for at least 2 to 3 times. Then only you will be able to understand the actual concept. Then only you will be able to actually understand and visualize the concept deep in your mind. And then thereafter, you won't forget throughout your life. Because these are the concepts. They are just like bicycling. You will be not able to learn bicycle or swimming by just somebody else advice. You yourself will have to jump. You yourself will have to ride the bicycle or swim. Then and only then you will be able to learn it. So for this type of the examples, you will have to first visualize the same thing in your mind with the help of the left and right hand rule. Try to apply and then see, then confirm whether you are getting the same direction or not. Thank you for watching.